Yes, good morning, Tala and your team, Alfred, Lawrence, Lydia, and Musa, and the rest. Hope you have started your week very well. Last time I did something modeling of demonstrated modeling this box culvert, single cell, and previously I had hinted on the wing wall. So if you look at this wing wall is in line with, is parallel to the road. But I said we can model the flaring type, which flaring type will more or less be in line with the kind of field we have and controlling soil getting into the apron slab. So but of course they perform the same thing. So what I wanted it to demonstrate how I've been doing mine using modification of the wizard. So I'm going to proceed and demonstrate that. So here I'm going to remove this wing wall and then develop one model, the flaring type with the apron. This one has no apron, and this will be very expensive in terms of maintenance, special maintenance, because water at the outlet and inlet, water there will be piping. So you have to do an extra treatment at this point, and the inlet and the outlet. So that is what it is. So I think the first step is to remove this by deleting it. Or we would have actually rotated this by 45, but let me do it my way. So here I will delete this delete morning. I will delete this. So the deleting, now you can see I have. So down here, this is the spring constant generated by Midas wizard. So we first leave it. We shall talk about it later. So I think what needs to be done is to do the offset. I told you modeling is basically an art. You need to know what you're doing. If you know the structure you are working on, then definitely you know what to do. So here I'll be offsetting, or they call it translating. Now this is the axis is moving to the right is the x, and moving up here is the y. So I want to move down here, so that is in the y direction but negative because it's in the opposite. So giving it like 4 meters. If I do 0, negative 4, then 0. There we are. But I also told you the flaring I'm taking 45 degrees. Let's read and you'll find out. Depending on the angle of repose and the height of field, you will know the angle. So here we'll be taking 45. So this is the line. This is the external wall. I'm doing that. So I will pick this and then offset that by, which is in the x direction, and negative. I will put it on negative because 45 means is 1 to 1. So I put 4. And then no need to indicate the other one, and I have my 4 here. Then the same thing apply here. I remove the 4, moving in the positive direction. I would get that. So having done this, I'm able now to remove these nodes that are up. So you can find that when I view, I will find I only wanted the base. I only want to do the base here. So if it is the base I've done, because the apron is, this is the apron area. have done now this, extended this. So these knots are offset at 1 meter. So at the end of my wing wall, I think I'm assuming that's about 1 meter height. So I'm able to delete these knots. And then even this the bottom springs, I don't need them for now. We are going to come up with our own. So if you look at it now, I have done for you this is the area of the apron. So there's something we are going to do. What is you have to, from here, they have already, if you go to properties and sections and we look at the thickness, they are already thickness given by the wizard. So our wing wall, I'm going to adopt number 4. Number 4 is 0.457 something. So for this, I'm going to do for the wing wall. So I go to knots model, come to auto meshing, and then make sure you do the knots is active, and then maybe quadrilateral and triangle, and then I think the division maybe is 0. No, let me leave it at 1. So the grade is given here, and then the thickness I'm doing 0.45. So I just come here, I make sure I highlight this, that, and this, and then I'm apply. Then again I do for this one, and then I do for this one, I apply. My wing walls are already in place. You get it? So if I view, that is the wing wall I have. It's different from the previous one. So how do I do the base? And then the base now is very important that so for the base I just connect this to give you a apron. So I go, maybe I use the same thickness, but yeah, if I use the same thickness, then for demonstration purposes, but you can also model that, then I'll just make sure I highlight this, and then I'm done. You are there. You are, one more do you need? You are done with this. As simple as that. Remember, at this point we have at the end here, at the exit point, we have cutoff beam. So this cutoff beam we can simulate using fixing this end here, so that become rigid at this point. So that is something that we need to know. What would be, so I think that is what I've done, just to demonstrate for you the wing wall. How do we model it? I just wanted you to know it is very easy to model, and then now all we need is to do the other side. This side also I can mirror this, or of course, let me see if I'm to mirror. This is 0, this is 18, so I mirror by 9. So I will try and see if I can mirror this so that it is my work. Sometimes it's very difficult to mirror. So you're mirroring this by, so you're mirroring, mirror is here, and then mirroring this, and in the y direction, the y, and this I think 9. So you make sure all the knots, because you're mirroring planar surface, make sure all that and we are done, my brother and sister. You have your you have your thing done and ready, but it's not yet ready because you have to apply the load. So the first thing I want to test is I will have to apply the boundary condition. So the boundary condition, I've already told you, is basically boundary condition is to apply the spring constant. With spring constant, so spring constant, I told you, we shall learn more, is so quickly the
bearing capacity divided by the allowable settlement. Settlement range between 20 to 25 millimeters. So I would quickly go here, highlight that. I've highlighted the base. I want to apply the surface spring, and my surface springs in the x direction. I'm giving it half of the vertical one. The vertical one, maybe if the bearing capacity I'm enhancing is about 500 kPa, and the allowable the function is 20, that becomes 5,000 kilonewton per second. So when you apply, you have that. So that is the spring constant that you have, and basically I can test this before applying the load, but there are already loads on the site, except for we have loads here, but they are not on the they're not on the what? They're not on the wingwall. That can come later. So if you run that design, you have money. So you're going to have here what would be the bearing pressure. So soil pressure down here. This is very important. There's something you're going to see. Soil pressure, this is how it is. You can see concentrating at the edge and narrowing towards the what, reducing towards the center. Now if this is something that you need to do, let me save it. Some model. This is today's date is 24. Human money. So that is what we save. Yeah. So I have done the model, which is done. I think we can do that. This we shall go and do the loading.